What's up, math fans? It's Friday. I'm gonna try to make this quick so I can go to the library. So today we're talking about literal equations, and literal equations are kind of like formulas. They're equations that we've been talking about: one step, two step, x on both sides. It could be whatever. They're equations with more than one variable usually, or more than one letter. So think about what formulas are used for and how you manipulate them. For example, I live in New York, I want to head down to Philly, so I'm going to get in my car, I'm going to drive 60 miles an hour for 2 hours. How far do I go? Well, you need a formula for that. Distance equals rate times time. I just told you that I'm going 60 miles per hour and I'm doing it for 2 hours. So multiply 60 times 2 is 120. And what's cool is the hours cancel out because this is a numerator, this is a denominator. And I left with 120 miles. And there's my answer. My distance is 120 miles. That's using a formula. Literal equations is not really putting in numbers. When you're doing literal equations, when you're solving literal equations, don't try to get an answer. You're not getting an answer, you're just manipulating the puzzle pieces of a formula. So, instead of d equals r type t, maybe I tell you, oh, my distance is 500 miles and my rate is 50 miles an hour. How much time would it take? So now you're trying to solve for t instead of d. So you want to manipulate the formula depending on what information you're given. Okay, so this time, if I said I got 500 miles, I'm going 500 miles and I'm going 50 miles an hour, solve for t. Well, how do you solve for t? You plug in numbers and you try to isolate the variable, right? Forget about this. Literal equations, no numbers. That was just an example of why it's helpful. But literal equations is in general, if I don't know the numbers and I just want to move the letters around. So think about solving for t here. How would I do that? What would I do if I knew what to do? Because all these letters, I don't know what to do. There's no numbers. Let's pretend there was numbers. Let's say, I'm actually going to do this one first. Maybe it's easier for you, maybe it's not. Let's say I want to solve for x here. Okay, you're used to that. Solve for x. I always get that. What would I do if I knew what to do? I don't know what to do here, but I do know what to do if it was 2x equals 10. One-step equation, divide by 2, and x equals 10 divided by 2 is 5, and I'm done. Just in case you don't know that 10 divided by 2 is 5, if you leave it like this, x equals 10 divided by 2, 10 divided by 2, 10 divided by 2, the same thing. You're not wrong, you just could have gone further, you could simplify further. In math, always simplify further. So do what you would do if you knew what to do. I'm going to divide by the coefficient, and x equals 10 divided by r. This time I don't know what it is, I can't simplify further, so I have to stop there. Here you don't have to stop there. Okay? Do what you would do if you knew what to do. Gonna get harder now. What if I want to solve for y here? I have no idea. So let me do what I would do if I knew what to do. Let me get this out of the way and let me think about this. So if you're sitting in class and you get something like this and you don't know what to do, go to the side, go to some scrap and say, well, I don't know this one, but I do know this one. What would you do? That's a two-step equation. I saw that video. I know what to do. Minus 7. Okay, 2y drops down. 15 minus 7, I don't know, what is that, 8? Okay, divide by 2, and I get an answer because I know what 8 divided by 2 is. It's 4. Get an answer. Here, I don't really want an answer. I just want you to isolate the y. Get y alone. Isolate the y. Get y alone. So do what you would do if you knew what to do. All right? Think about what you just did. What did we just do? And I erased it on purpose because you can always rewind it and check. What did we just do? You divided by r, add, subtract. Oh, okay, subtract the s. Here's where it gets crazy. Everybody's always looking at t minus s and they're like, that's ts, that's st. No, it's not. You don't know what it is because you don't know r, you don't know s, you don't know t. Just write what you see. See how it says t minus s? Write t minus s. Going down, going across, the same thing. ry, going to drop down. And now I'm going to divide by the coefficient. and y equals t minus s over r. Y equals t minus s over r. That's it. Write what you see. If you can do the math, do the math. If you can't, you don't. Leave it like that. Manipulate the variables until you can't anymore. Y is isolated. Good job. Here's a little more difficult one. Okay, what are the directions here? Solve for y or x. I'm not going to answer you. Both is impossible. I'm going to say solve for y here. Isolate y. You might get directions that say solve for y, isolate y, or even express y in terms of x, which means get the x out of there. So I will. Now people see numbers and they're like, numbers, I can put that together, that's 16x. No, it's not. $10 plus 6 potatoes is not 16 potatoes. You don't know. Don't combine dollars and potatoes. 10 plus 6x is 10 plus 6x. That's it. 2y drops down. Did I do it? Did I isolate y? Almost. Divide by the coefficient. Divide by the coefficient. Here's where it gets crazy. You are allowed to divide. Even if it has an x next to it, you are allowed to divide the coefficients. And if you remember fractions from middle school, I divide the 10 by the 2 and the 6 by the 2. Okay, so I'm going to get y equals, if you can't see what I just said, I'm going to rewrite it. When you divide by 2, you do it everywhere. You do it here and you do it here, individually. So this is going to be 5 plus 3x. The end, y is isolated. If you know somebody who's good at graphing, they usually write it as y equals 3x plus 5. They switch it because it looks like y equals mx plus b. But I don't want to confuse you. That's the style you put it in for graphing. This is cool for now. Check out my video on graphing. All right, so go back to the beginning. Did you learn anything? Now, what if the directions were isolate t? So let's say you know d and r, you want to solve for t. How do you solve for t? Divide by the coefficient. Nt is alone. Nt is d divided by r. Time equals distance over rate. So literal equations help you in formulas, they help you manipulate variables, and sometimes they're just for fun. Thanks for watching. I think you got the point, but I'm going to do a challenge one anyway, just because I am that motivated. In fact, I put this on a quiz recently. We got 9x minus 24a equals 6a plus 4x. Directions say solve for x, isolate x. So I want x on one side and anything else on the other side. Everything else on the other side. Well, let me bring my x's over there. I'll subtract 4x so that all my x's are on one side. Goodbye, 4x. 9 minus 4 is 5x, and everything else drops down. Is x alone? Not yet. Let me get rid of the 24a. Cancel out 24a. 6a plus 24a is 30a. 6 apples plus 24 apples is 30 apples. 5x drops down. Equal sign drops down. Got x alone. Almost. Divide by 5. Divide by 5. X is alone, and you are allowed to divide coefficient. 30 divided by 5 is 6a. 30 apples divided by 5 friends. 6 apples per friend. Now you know how to manipulate literal equations. Not solving them, you're not getting an actual value, you're just moving stuff around. Alright, thanks for watching, see ya.